is the question? Yeah, I mean, we can, yeah, Joyce and VP, we can call. VP, may I know your name just out of interest if you are happy to share, otherwise it's fine. So yeah. Shall we proceed? Are we good with first question? Yes, no? Please talk to me. I feel already like, because we are meeting for the first time. Okay, perfect. Thank you, Nishita. Thank you, Joyce. So let's move ahead. Cool. If you don't want to disclose, it's fine. So this usually we keep for working. I thought we can calculate if you're interested, but in interest of time, let's proceed. So even again in the same category, you may be given very complex picture. You may think that question is very difficult, but at instance, you may find that it's super easy. Just give me a moment. Let me put Nishita, I did not get your question. Can you repeat? You are not able to see general chat.
Right, the chat page or the chat section is just direct messaging. I'm not sure if you're aware of that.
Okay, so you want me to, okay, send, okay, you can just choose a drop down. There would be a drop down called as like if you want to message someone, everyone, there would be a drop down. If you can put it to everyone, or I mean, feel free to direct message me also, either ways. Was that a question or like? Nishita, I mean, can you see drop down? You can message it to everyone also. I mean, feel free to do, I mean, it's fine. Cool, yeah, let's proceed. So this is again a next question. A market risk manager would like to analyze and forecast security performance. So there is a market, earlier we had a credit risk manager. Now we have got market risk manager. I hope, I mean, you also be in those seats like credit risk manager, market risk manager for future, of course. Yeah. So you're trying to understand the focus of security performance and sense and has obtained the historical time series for the security. So basically you have obtained the returns time series, how the stock return has been. So you have time series data for stock return. The manager consult colleague from a quantitative analytic team who provides the following partial autocorrelation plot. So in this case, like we have got autocorrelation and partial autocorrelation graphs over here. Can anyone tell me what is the difference between autocorrelation and partial autocorrelation first before we proceed? See, in a single question, I will try to cover a lot of your aspects. So in this question, I will cover the difference between autocorrelation and partial autocorrelation. And we will talk about autoregressive, moving average, and I will touch upon the stationary and non-stationary characteristic of this time series also. So single question, multiple learning objectives. So that's how, in fact, your objective should be. You should be in a better position to learn a lot from a single question. So quality over quantity. I mean, it's not objective that I mean, we solve 1,000 questions, but there is no learning. Rather, we solve few questions, but there should be some value addition in you. So yeah, coming back, what is the difference between autocorrelation and partial autocorrelation? Anyone?
It is not clear to me. Can you please explain the difference?
Sure thing, I will definitely.
Thank you.
So first of all, autocorrelation and partial autocorrelation. When we talk about autocorrelation, it is a correlation. Say, for example, if I'm just talking about the today's return versus prior day return, what is the autocorrelation? So that's where we talk about autocorrelation. But when we talk about partial autocorrelation, we try to understand at certain time window. So there is element called as a tau. Say I say 12 months. So what I'll do instead of YT, so one parameter would be YT and another parameter would be YT minus 12. So this partial autocorrelation may be dependent on your tau. So you're trying to understand, I mean, if there is a like kind of a correlation between January versus last January data, that's where the autocorrelation comes into the picture. But when we talk about just autocorrelation, so this is PACF, partial autocorrelation, and F stands for function, partial autocorrelation function. And over here, we just talk about autocorrelation, the correlation with its lag value, one lag value. And here, lagged value can be anything. It's very generic. Is that clear, first of all to all of you?
It is not very clear. So the autocorrelation, the simple one is just for one lag, and
Yeah.
the partial autocorrelation is it's more than one lag, right?
It can be with anything. Say, for example, if I talk about autocorrelation, I would try to understand Jan and Fab data. So this is the lag is just one, a one prior value versus current value. You are checking how much they are correlated. And when we talk about partial autocorrelation, this lag can be anything. So it can be January to prior January or January to June. So this tau, so this lag term can be anything. That's where we talk about partial autocorrelation.
Okay, I think
Sir,
it's clear. Right.
sir, is it not similar to the like regression, multi-regression thing, like yt equal to alpha plus beta yt minus 1 plus yt minus 2? So it whatever the beta 1 or beta 2 is could be the autocorrelation, isn't it so?
See, yes, to some extent, intuitively these things are related, but directly to say that these are related, I mean, no. But yeah, intuitively, because over here you are also talking about like essentially the actual objective is to estimate, understand YT from YT minus 1. Because see, everything you do in risk management is understanding the future. So you have got past data, you're trying to understand the future. So regression is a tool to regress this YT. Okay. So once you have regressed it, you try to understand. So this is estimation. So from regression, you do estimation of YT. And once your actual YT has arrived, okay, then you can relate. I mean, to understand your how much accuracy of modeling or estimation is, you try to understand all things, all these things, like autocorrelation, what you estimated versus this. But I mean, these are quite relevant, but not directly. They can be, so for, if I talk about regression, it is objective is estimation. I'm trying to estimate the future value. Whereas when it comes to the understanding the autocorrelation, so because I'm estimating, are the values actually correlated? Like, is YT minus 1 actually correlated with YT? If it is not correlated, then my estimation may not work well. I have to search for some different approach. Does that answer you? I mean, are you able to relate what I'm saying?
Yeah, I can. My point is like yt. It could be yt minus 2 also could be included, right, in that equation.
Of course you can. Of course, yes, Sanjay. You can include.
Okay.
So that's where we have got AR1, AR2.
Yeah,
So,
it makes sense. Yeah, that
yeah.
makes sense.
Okay. So any questions from anyone? See, I mean, the objective is to make you think. So this is how, okay, Joyce, great. So let's move ahead. Anyone has any question on this? Please get maximum value from whatever tiny amount you have paid. That's the objective. So feel free to ask any questions, please. I would be happy to address that. Okay, so let's move ahead. So if you notice, and let's talk about auto regression now. So when we talk about AR, it is like you are trying to estimate YT from YT minus 1. So you have got one intercept term, and see, notation may be different, YT minus 1. So to derive the current return, you are using the past return. So that's the autoregressive. If I include two past values in my regression, that is called as a AR2. Are we good so far? See, autoregressive is little easy because it's just the past value. You are trying to estimate the current value. But when it comes to, are we good with autoregressive? Then I can touch upon moving average. Then we can relate what could be the eligible answer for this question.
Yes, autoregression is okay. Thank you.
Yeah. So now let's touch upon moving average. See, moving average is, say, your time series. If I just draw a stationary time series, it will look like this. Your returns at a times may go up. So eventually these will turn, this is a mean. This is an average of the time series. Eventually these will converge. So if during COVID, when stocks had gone down, eventually it came up. So it's a tendency of most of the variable in nature. Even if you look at the any natural phenomena also, everything has a tendency to reach out to mean. So yeah, coming back, but yeah, if there could be shocks also during COVID, it was not till this, it went like this. The shock was quite bigger. Your returns went super down. So for modeling those kind of scenario, instead of using the lagged value of the returns, what you use the shock. So you have got intercept term plus you have, say, like this can be the notations can be different, but yeah, you use the yt minus 1. So this is a shock. When I say epsilon t minus 1, it is the lowest value. It was a shock that was observed in one lagged value. Whereas when we talk about auto regression, it is yt minus 1. That is your one lagged value, actual value of the variable. Wherein when we talk about moving average, we use the shock value, the something which has gone very on a very low side, or vice versa. I mean, you can take upper side as well, but in usually risk management, we focus on the lower side of the data. Are we good so far? Auto regressive moving average, is it clear to you?
Can you
Okay,
repeat that last line, please? Like, what
yes.
would be the lowest side? Well, what is that thing?
Yeah, so when we talk about epsilon t minus 1, it is a shock. So when I say shock, wherein your market has dipped. So when it has gone very low, say during COVID, you might have noticed all the indices went down. So that can be tagged as a shock. So under moving average, you look at the what was a past shock. So if I just talk about recent scenario, see, there could be many series of events, but if I just recollect, yeah, recent one also, if I talk about Israel and Iran war. So what was the impact? What was impact of that shock? You can try to use that and try to regress the current value. So why in this way, you can you regress the current value based on the past shock. So it is useful when you have got the volatile market. Are we good so far?
Okay, so the MA in your equation is YT basically. So the YT depends solely on the phi plus the epsilon.
Epsilon, lagged epsilon, and there would be
Lagged epsilon.
yeah, and there would be some coefficient. So it is not
Yes.
your entire epsilon, but portion of it. It could be 80%, 90%. That depends on the model.
Okay, so in the end, you're trying to calculate the Y.
Yeah,
right?
absolutely.
Okay.
Yeah.
Thank you.
In both cases, we are trying to estimate, say, if I talk about stock returns, in both cases, auto regressive and moving average, I'm trying to estimate my current returns. That's my objective. Are we good?
Yes, it is clear. Thank you.
Perfect. So let's focus on this graph now. So I covered a lot of things: autocorrelation, partial autocorrelation, auto-regressive, moving average. These things we talked about. Now let's come back to the question. You are given some pictorial representation of, say, some stock, and you are given a correlation and partial autocorrelation. So when you are trying to understand, so majorly, if you are asked whether from the plot, if you are asked whether it is auto-regressive moving average, it is best to refer to the partial autocorrelation. graph. And in this case, you may notice that the initial two values are slightly bigger than whatever rest of the values are. So initially, we had some higher correlation, but afterwards, when we try to estimate the current values from past to lagged value, so for all the smaller data points that you see in this territory are derived from these two values. So it is clear cut a case of AR2. If this would have been like there would then be three sticks bigger, and afterwards it would have been smoothened, then it would have been case of AR3. Are we together?
Sir, one question. Are we at T0 or at T30 in this question? So I'm just confused.
So see, when you were like currently you are at here, but when you try to estimate, say you started here, but say on a second day, you try to regress your returns from your past to lagged value. That's how I have plotted. So you can say this is y0 on y2. This one. So y at regress it, and I have arrived at the y. That's why it has smoothened. So, and eventually I have plotted what is a correlation between the y2 and the daily return. So as I said that it's 1 in this case. So tau is 1. It's not really 12. So this graph pertains to the tau is equal to 1. It's kind of a same autocorrelation only. But because in partial autocorrelation, you try to regress your value from your past to lagged value, this graph has smoothened.
So we basically do not use autocorrelation because it is not interesting in this case.
Yeah, that's correct. So that was just I just want, I mean, to in this context of this question, only partial autocorrelation was relevant, but I just wanted to make you understand the difference between autocorrelation and partial autocorrelation. That's why I brought this complete diagram. Otherwise, the lower portion would have sufficed for this question.
Okay, and when would we use the moving average, for example?
That's a fantastic question. So if you notice certain volatility, like say for example, in this case, these two were quite together. So, but if you notice something like this, so if you got lower sticks, higher sticks, and then it got smoothened. So say for example, there are 4 sticks which are quite volatile, unlike these stable ones, then you can say moving average and a 1 or 2 based on how much volatility volatile it is.
Okay, so if there's lots of volatility, we would have used the moving average.
Yeah, that's correct.
Okay, because
Yeah.
this is basically the unpredictable unpredictable errors.
Yeah.
And how would we distinguish between applying moving average 1 or moving average 2?
Okay, so yeah, good point. So if you notice, there are 2 sticks after which the graph is smoothened. So basically that indicates the AR2. There are 2 sticks, right? After which this autocorrelation plot has smoothened. That's why we say it is AR2. If there would have been 1 and afterwards it would have smoothened, then we will call it as a AR1. And likewise, I mentioned if there are 3 sticks like this, and then it's smoothened, then you say it is AR3.
Yes.
Okay. And I think there is one more question in chat box. Let me have a look.
So, sir, I'm just confused. So you are predicting AR zero. So you are predicting 0 by 1. So it should, like, why is it not AR 1? Like only one stick is there, right? So as like to.
Sorry, can you repeat, Nilesh?
So you are predicting this 0. Okay, you are predicting this 0 time 0 with one lag, which is t minus 1 or t by t minus 1.
Mm-hmm. See,
Which has only one stick basically. Like if you compare the first first stick with the second stick, it would be only one stick, right? So
so see, see, firstly, at T0, you are comparing YT with YT. That's why your correlation, if I call it partial autocorrelation, is 1. Okay. But when you are at 2, it is slightly lower. It is 1. It is slightly lower than, because over here you are actually comparing 1 day with a 0 day. Earlier it was a comparison with itself. So that's why it was 1. Now it has gone down a bit. Gradually it will go down, but it has suddenly gone down. That means that you are trying to regress using two values, two past values, that is your first day and 0th day for your second day. So for second day, you have used your y0. So let me just write it notational wise. So to regress y2, you have used the y0 and y1. So you are using two values. That's why it is AR2.
okay, yeah, then it makes sense. Yeah. Okay.
Okay. And I think there is one more question. It's I think if you're is AR autocorrelation? So Nishita, it's not autocorrelation, it is autoregression. So when I talk about AR, it is autoregression, wherein you try to regress your current day value. Current day variable can be anything. Simple example, you can think of stock return. You're trying to predict the current stock return from whatever you had in past. That is called as a autoregressive. That is called as a AR. Good so far?
Thank you for your answers. I'm sorry to go back to this. The moving average was pretty clear to me that it will regress on the past errors.
Yeah.
However, how would the data look like for moving average 1 versus moving average 2, for example? Because in the AR, it's clear, it's the number of sticks and then it smooths, but moving average is not that clear.
Yeah, see, that would be a practical case. I mean, I'll try to get some plot after this session. That's very good question, actually.
Thank you.
But pictorially, if I get some good explanation on MA2 in context of partial autocorrelation, I'll share that in the group.
Okay, thank you.
Shall we move ahead? Are we clear on this part?
Yes, sir. Thank you very much.
Most welcome. So on non-stationary part, can anyone tell me what is I mean, the common difference between stationary and non-stationary time series? Just, I mean, of course, you have got a good definition or criteria in your curriculum to understand whether your time series is stationary or not. But in general, if you are asked, can you tell me what is a general difference between one is already drawn in front of you and one other that you can think of? See, at our, like, the goal of the institute is to make you think. That's where see, everything is available on YouTube and Google. There is nothing missing, to be honest, but it is someone who would make you think. Just try to give stimulate your thought process. That's the objective. So coming back to question, I think we have constant mean and variance. Yes. So that's for Nilesh, that is for stationary or non-stationary?
Stationary.
Perfect. Yeah. So stationary time series as a constant mean. So this one that you see on the plot on the screen is a stationary time series. I mean, it is a cyclic. It has a mean. Okay. But if I talk about something like, say, this thing, so your variable is just keep on increasing. It's like, see, there would be, if I break down this, there would be small if I just try to fit in this non-stationary in this line, there would be slightly a characteristic of non-stationary as well. But yeah, eventually it will increase. Over a longer period of time, it will keep increasing. Unlike this, which is a cyclic, it goes up and come down. I mean, like in general, it tends to reach out to mean. But it is like in general, it will keep increasing, the non-stationary one. Whereas stationary one is, it has a constant mean, constant variance. So variance, when I say variance, this is a displacement that I'm talking about, displacement from the mean. Okay. So displacement from the mean is something variance that we are talking about, and the horizontal axis that you see is a mean. So when you have got constant mean, constant variance, it is the stationary time series. And when it keeps on increasing, it is non-stationary time series. Is the difference clear to you?
Yes, thank you.
Okay. Any guesses what kind of time series it is, looking at the autocorrelation graph? So if you were to interpret stationary and non-stationary characteristic, it is mostly autocorrelation. Any guesses?
I would say the based on the autocorrelation, it is non-stationary because it keeps decreasing, I guess.
I think it is stationary as variance still is constant.
See, try to understand. See, this is a plot of actual returns. Okay. And this plot is a plot of correlation between YT and YT minus 1. I mean, good. Actually, Nilesh, good point. You tried to think. Now I'll address your question. So this graph that you see, it is of autocorrelation. Basically, when I say autocorrelation, it is YT minus 1, YT minus 1. So if you notice, it is YT versus YT. That's why it is 1. And gradually it will go down, but it is eventually higher. So YT versus YT minus 1 correlation. So this plot that you notice is between 1 to minus 0.5. Ideally, it should have been minus 1. So it is correlation graph, whereas this is an actual variables graph. So directly comparing is something uh, which will not get us the right understanding that we are trying to understand. But yeah, uh, are you following? First of all, did you understand this graph that I've drawn is for returns? So say, for example, on y-axis, I have got my time, and on x-axis, I have got my returns. And I'm trying to understand how my returns are moving with time. Whereas what I'm doing here, it is t same on x-axis, but on vertical axis, I have got my correlation between my today's return with my prior return. Are we good so far?
Yes.
Fantastic. So Nilesh, good. Did you understand the difference between these two graphs? One that is on the top and one that you see in the picture.
Yeah, but still, I am not able to understand from the various perspective what
So,
would have been the.
so first of all, is it clear that this graph is of returns and this graph is of correlation? I'll come to that, how I can decide if it is a stationary or non-stationary. That's something I'll
Yeah,
get to touch
yeah,
upon.
it is clear. Yeah.
Okay, cool. So if having said that, if that is clear, then we will see for this kind of time series, your this correlation, this variable would be highly correlated with this, because you're actually, it is going up. Your past variable is able to predict the current variable. So you will get graph autocorrelation plot like this, because your actually your current variable is highly correlated with the lagged variable. So you have got very high correlation. But on the other hand, if you would have got the plot like this, say for example, initial would be 1 always because you're comparing, and this, and something like this, it has gone down also. So eventually you did a correct thing. But if you got something like this, then it is kind of, you have some ups and down, which indicates that it is this kind of series, that is your stationary time series, which at instances will have positive autocorrelation, sometimes negative autocorrelation. Whereas if you've got non-stationary time series, which is just keep going up, that will have this kind of autocorrelation, only positive sides. Does it help?
Okay, so if I repeat this in my own words, if we have an autocorrelation looking like the time series that is stationary on the right, like going up, down,
Yeah.
that is based, we can deduce based on this autocorrelation graph, there is a stationary time series. However, if we have only on one side, like only positive or only negative,
Perfect.
that is
Yeah.
non-stationary time
Perfect.
series.
Perfect.
Okay.
Perfect. That's perfect. Yeah.
Thank you.
Everyone, are we together? I just want to ensure that everyone is with me. Sanjay, Zu, Joyce, Priyanka, Nisheta, Nilesh, Udit. We can just confirm. So please confirm. Perfect. Thanks, Joyce. Everyone else, yeah, thank you, Priyanka. Please acknowledge at least. Nisheta, are you with me? Or like, I just want to ensure that we are, thanks, Sanjay. Okay, thanks, Udit. I just need to ensure that we are together in context of frequency. Perfect. Thanks. Thanks everyone for acknowledging. Let's move ahead. So with this, I think we covered a lot. 4-5 tough topics from the quantitative analysis we covered in the single slide. Okay. So